Good morning. My name is Yuval Bahar, and I'm working for LinkedIn and functioning as the president of the Open19 Foundation. I wanted to first apologize for not being in Mexico City today and to send my support and prayer to the people of Mexico. I had restrictions which were job-related restrictions that did not allow me to be there, but I hope we'll be able to actually have a good session over the WebEx. Go to the next slide. I'm going to talk today about the Open19. Open19 is a technology which has been developed by LinkedIn, but it is open source and will be enabled for everybody to use in the industry, and will be actually in production in the next few weeks. We started Open19 development with a very specific data center philosophy. The philosophy says that every data center element is a server. When you look at the servers as compute servers, as storage servers, it's just a server with a lot of drives on it. And even networking gear is actually a server. It's a server with a lot of ports on it. We're moving into a data center which is very scalable, and to do that, we actually eliminate all the appliances from the data center. We don't have appliances in the data center, no firewalls and no load balancers. Everything is actually becoming server and actually working as a server. We have multi-supplier for every element in our data center, which means that it's open source. You can buy it from a lot of sources for every element that you have. And finally, we solve in software what we can, and we build hardware for what we cannot solve in software. A few highlights of how we build data centers. Flash is actually key for our storage. We use Flash everywhere we can and everywhere we can afford. Flash is much more stable, much more reliable, and gives us performance which actually enables our app to be fully optimized. We do a scale-out environment where we actually extend our systems to be replicatable, which means we can take the system and put more of them to be able to scale our data center. That scaling of the data center is giving us the opportunity to actually have a very repeatable and a very manageable solution, no matter if it's small, like a few hundreds of servers, or it's huge, like 150,000 servers. It's exactly the same technology. We do this aggregation, which is very strong for our philosophy, meaning every element is independent. So there is no rack level management. There is no component level management, which is beyond the server. And that enables us also to be able to scale very, very well and to mix technologies, which are server technology from different suppliers, into one element you will see in Open19. We are also extremely cost optimized. We're trying to optimize every element in the data center to be able to create the most optimized solution for us. And now that we're sharing Open19 with the industry for everybody who's going to take and adopt this technology, we've been proven in our build-outs that the Open19 solution will be optimized compared to any other solution in the industry. If you go to the next slide, let's talk about the Open19 project. No, go to the next one. Next slide. No, back. Back. There. This one. If you look at the Open19 project, it did not start as an open source project. Open19 project started as a LinkedIn internal development. But once we shared this technology with a lot of our peers, they were really excited about it. So we understood that this is valuable for the whole industry. So we decided to actually open it up and give it to everybody in the industry. And I'll show you in a minute how we did this to actually make it the most accessible and most available for everybody who wants to build data center in any size, in any level of engineering team that you have. Even if you have a small engineering team, you will still be able to take Open19 and adopt it and have the support from the companies that will work with you and support for you. If you have a large engineering team behind you, you can actually take Open19 and develop this in a different way. Go to the next slide. We had a few goals when we started developing the technology. The first goal was actually find a common standard that applies to every location, every co-location, every edge location, and every data center location. And the only element which is common to our data centers today is all of them have 19-inch racks in them. So we decided that 19-inch rack is our environment, and that 19-inch rack will let us build data centers, which means integrating servers, storage, and networking into the same rack in an optimized way. We wanted to create a solution that will be as scalable as possible, from very large to very small environments using the same technology. The LinkedIn example, our smallest environment is 16 servers. That's the micro data centers that we build in the edge. The largest one can scale up to 150,000 servers in our data centers today. And if you want to extend it beyond it, you can take it extend it beyond that. We wanted to be in a position that we reduce two elements which are very important for data center integration. One is the base cost of a rack, and the second one is actually being able to run really quickly and bring from request to online data centers in a fast cycle. We expect the ability for us in our data centers to be able to bring data centers online 5 to 8 times faster than we do it today. So if it took us 3 to 4 months to bring online a data center, we expect that number to actually go down to weeks to be able to bring online data centers with tens of thousands of servers in them. And lastly, we wanted to actually create an ecosystem. We understood that to be able to successful in this project, we need to have an ecosystem, both of our peers, people which will use the technology, as well as our suppliers for servers, storage, and components. And I'm really happy to say that the ecosystem has been established, so we met that goal very well. We go to the next slide. We had a few elements which were known goals. The known goals were actually very important for us because they are actually setting up what we should not do. So we didn't want to be in a position that we actually create a proprietary form factor. There's a lot of proprietary form factors out there, if they're commercial or open source, but they're all proprietary. None of them is interchangeable, none of them allows different suppliers to be playing in them, and none of them actually enables the suppliers and the operators to innovate. We wanted to avoid that, and we decided internally that if we are creating another proprietary form factor, we basically failed in this project. We wanted to create a non-restrictive environment where we can develop things based on engineering demands and requirements, and not define specifications which are really just enabling another lockdown to a different technology. And lastly, we wanted to eliminate any bureaucracy from any organization. We did not want to operate in a very highly bureaucratic organization. We wanted to operate in an environment where we actually can be free to actually innovate and develop, but at the same time be able to work in an ecosystem which is common. We go to the next slide. What you see over here is Open19. Open19 is built out of a few elements. The elements that you see on the right side, the green one, are what we call cages. Those cages are just mechanical structures that hold the servers in them. What they're defining is three things. They're defining the form factor of the servers, which is common to everything. They're defining the interconnect for data and power, and they're defining common power distribution and network distribution. That's what the cages define. We have 4 types of servers. All of them are based on RU level. We have a half width, which we call a brick, a double wide, which is a full 1 RU server, a double high, which is a 2 RU server, and we have a new version of the servers, which is half width 2U solution, which is targeted for GPUs. There are 2 elements which are common over here. A power shelf, which distributes 12 volts to the whole set of servers, so you can eliminate for every server the power supply. Just by doing that, you can save about $300 to $350 per server, which is very significant when you go to large numbers. The second one is a networking switch. The networking switch enables us to do common data distribution and give very high bandwidth per server. We can give 100 gigabits per second for every half RU, 200 gigabits per second per RU, which is very, very significant, and it will future-proof the technology for the next 5 to 6 years. Go to the next slide. If you look at the backside of that cage, you will see something which is very special. And that's a cable that we have on the back over there, which creates a virtual chassis in reality. What it does is a cable which we call a snap-on cable. It's a cable that snaps to the back of the cage. The cage is completely passive. There's nothing in the cage except sheet metal. This cable snaps to the back of the cage, and by snapping to the back of the cage, it creates a blind-man connectivity for the servers, both for data as well as for power. So the servers have no cables coming from them. It's just a set of bricks, what we call bricks, which are pure servers. This is something which makes it very significant different for us, both from an operational perspective on how we build data centers, as well as from a cost perspective. The cost of that cable is 1/5 of the cost of a standard cable you would use to connect 50 or 100 gigabits per second to a server. Go to the next slide. The picture you see on the left is actually in real life. This is a picture from CB in Germany about 4 months ago. And you can see in it that there is a combination of 5 different suppliers for servers, which are sitting active in the same cage, running together. This is probably the first time in the industry that you see HP Enterprise, Supermicro, Flex, Inspur, and a LinkedIn homegrown server coexist in the same chassis. This is not unheard of. These servers were actually fully functional, up and running in the event itself, and all of them were working together in coherence. This shows very, very strongly the aspect of disaggregation, where the server in slot 1 doesn't care who is the server in slot 2. It can be the same server as me, but it can be a completely different server. And this was a good demonstration for that. What you see on the right side is the cage with the cables integrated into it. This is a prototype version of the cables, so they're a little bit ugly, but we promise that in production this is going to look much, much, much nicer. But this is just to show you how the connection of the cables is happening on the back. The perforation you see on the back also is to enable very good airflow. You go to the next slide. This is the brick cage. And it's a detailed definition of the brick cage. We have currently 2 versions of that, a 12 RU version and an 8 RU version. It all comes in 2 RU modularity. So if you see the septum on the top picture, it can be removed and create a 2U space in the cage. Each one of those 2Us can take 4 bricks, which are half width, 1 RU. Can take 2 double high half width, which is like half the size. Can take 2 double wide, which is a full 1 RU solution, and 1 double high, which is 2U. We did not go beyond 2U right now because our assumption is that if you want to go beyond 2U for your component, you're going to put it outside of the Open19 and still connect to the Open19 network, but you're going to put it outside of it. The snap-on is in the rear. You can see the openings of the rear of the chassis where the snap-on cables fit. If you go to the next slide, these are the form factors that we defined for the bricks. We defined a brick which is half width 1 RU. We have a new version which is a half width 2U solution, mostly for GPU solutions. We have a double wide, which is a clean 1 RU solution, and we have a double high brick, which is 2 RU solution. We have linear and power growth, linear data and power growth. What that means is the bigger you are, the more data you get and the more power you get. Just for example, if you take the brick gets 400 watts and 100 gigabits per second. If you take the double wide brick, which is a full RU, you get 800 watts and 200 gigabits per second of data. If you go for the really large one, the 2U solution, you get 1600 watts and 400 gigabits to the server. This is the first in the industry where a server can get so much bandwidth connected to it in a relatively non-blocking way. Every connection is built on 25, 50, 100 gig basis, and we actually allow to be in any mode that you want to operate, in 25, 50, 100 mode, and in the future we'll be able to give 200 gig on that interface instead of 100 gig, as well as 400 gig per brick. which means that you can go almost 1.6 terabit for the large server in the future. Next slide, please. This is a special switch that we built for the Open 19. That switch is enabling us to do right now only 50 gigabits per second to the server because it's only 3.2 terabit. This switch is supporting 48 servers. So it can support 48 servers, and we created in the switch also an out-of-band network, which is a 1 gig/10 gig management system. It receives 12 volts, so we don't have power supplies over here as well, saving some money. And it has 8 100 gig uplinks that go to the interconnect to the network. The CPU is very strong to enable to do very fast convergence. This is a white box designed by LinkedIn, which will be completely open, and you'll be able to source from at least 2 to 3 suppliers anytime in the future. Just a side note on that, some of our peers did not feel comfortable to go and use that switch. We have a solution to that as well. If you prefer to use a standard switch, you can use a standard switch with Open 19. There's a special cable instead of the standard snap-on cable that will enable you to run a standard switch as well. You go to the next slide. This is the power shelf. On the power shelf, we had a few things that were very, very important for us. First, we defined 2 versions of that. One is a 1RU 9.6 kilowatts, and the second one is a 2RU 19.2 kilowatts. The second thing that we did is we created shared modules, so all the modules can fit in all the slopes. We have a Gigi port on it, and there's a Linux running in the back of that shelf. The shelf is actually capable of taking any AC and any DC in any range without changing the shelf. The only thing you need to change is the connection on the back. There is a standard connector on the back which connects to a whip cable. That whip cable is giving you the option to connect to different types of inputs, if it's AC or DC, and if it's low voltage or higher voltage, single phase, 3-phase, all those can actually be connected to the same shelf. So in any location that you have, you can use the same shelf. We have multiple sources for that shelf as well. The one thing which is very special about this shelf is that it creates every server has its own protection and its own monitoring, which means unlike other solutions which have bus bars, if one of the servers fails, it actually fails the whole chassis on the whole rack. In this case, servers do not impact each other. So each server works as an independent unit, and if it has a fault or it's shorting the power input, the only thing that will happen is that its input feed is going to be shorted. Nothing else except that. We can also monitor power cycle and reset each and every one of the servers independently through the power shelf, and that's a huge advantage for us when we do debug and we do a bring up of the system. There is an option to connect this to a battery backup unit, a BBU, which will work in coherence with that power shelf and enable you to be able to run this with a no UPS system environment like in some of the edge applications that we have. We go to the next slide. So to summarize the benefits of this platform, you get any 19-inch rack, so any location, wherever you are, if you have a 19-inch rack, you can use the technology. We have fully redundant infra. The power shelf has an AV2N redundancy. You need to get 3 failures for the power shelf to actually create any disruption, which is never happening for us. Fully disaggregated. Every server is independent. There's no relationship between the servers, and every server operates independently. Short integration time. We have proven in our labs that we can integrate those racks with those servers 6 times faster than what we integrate the standard server environment, which for us is enormous because it means for us that we can change the way we build data centers, and we did that. And I think anybody is going to look at this, and we're going to post some videos very soon, everybody's going to look at this, we'll be able to see why it is much faster to do that. It's very, very easy. It's becoming Lego to be able to build a data center instead of really complicated cabling and installation process. We're leveraging existing servers, so you will see a lot of Open 19 servers coming into the market very soon because they can actually leverage their motherboards into this Open 19 form factor. The one thing which is very interesting about that is that if you notice, we have not specified the server. We did not say what's in the server. All we specified is the form factor and connectivity for power data, and each one of the server suppliers is innovating by itself and creating its own servers. So you'll have a variety of servers from a variety of suppliers to be able to get what you need for your data center. This is very power efficient because this is operating on a 96 to 97% single stage from high voltage DC or AC into 12 volts. This efficiency is very difficult to achieve in a two-stage environment, and we're able to achieve it over here. Multi-server tiers, you saw based on the type of server form factors we defined, you will see a lot of servers from different types and different configurations. And we believe that this is at least by 25 to 30% more cost-effective than any data center architecture. Give you an example, at LinkedIn, when we're building a new data center right now, our estimate is savings of millions of dollars for every data center just because we're shifting to this technology. We go to the next slide. There are a few deployment models that we've seen for that technology. One is traditional for data center operators. Traditional data center operators in any size, from a few thousands to a few hundreds of thousands, they just build it the same way, just much faster and lower cost. The other deployment model we've seen, which is very common in the industry today, becoming more common, is bare metal cloud services. It's coming in the edge mostly, but it can actually come in the data center as well, where you can go and actually lease a slot. So companies like Lepdol Mine, like Equinix, are actually considering building a slot version of this. When you actually come as a customer, you can lease a slot from them. You don't have to buy the whole data center or the whole hallway. High efficiency off-site integration. A lot of our partners are off-site integrators, people which do what's called rack and rolling. These guys really love this technology because it makes their work much, much more efficient and much, much faster to be able to integrate, which means that it reduces the cost for them to the integration. And lastly, edge platforms. Edge platforms are really critical over here. Edge platforms in the next 4 to 5 years actually supersede the size of the number of servers footprint than all the large mega data center operators combined. These numbers are not disputable. They're going to be much, much larger deployment in the edge versus the data centers. And this technology is actually tailored for edge exactly. And it's actually targeting edge because of the fact that you can build this in a very small form factor and you don't have to go to a very robust data center solution. If you go to the next slide. Let's talk a little bit about the Open19 Foundation. The Open19 Foundation is an organization that was created to be able to encompass the technology that we have in Open19 and be able to share it with the whole ecosystem and the technology partners we have. If you go to the next slide. The foundation was established in May of 2017, this year, just a few months ago. We had a launch event on the 23rd. That's where we actually started collecting the support from companies and from individuals. It's a community-based organization for open source hardware and software. And Open19 is just one project out of many. There are other projects over there, software projects and hardware projects, which are going to be in that organization. We have currently 5 founding members at 27 companies as members and about 1,200 individuals. This is without precedent at such a short period of time, which is about 3.5 months. We were able to establish almost 32 members, which are full-time members, companies which are committed to this technology. And we will, as a result, you will see an ecosystem which is live and thriving. If you want to join this organization, we are in the stage where we're forming and establishing it. You just need to go to www.open19.org, and there will be a very simple form to fill out over there, and you can join as an individual as well as a company. We created a very flat organization in the foundation. Every member is equal. So every member has the same rights and the same commitment. The amount of commitments that you have are very, very limited and actually only restricted to how much commitment you want to put in. Based on that commitment, you can actually make a decision if you want to contribute if you want to consume technology, or if you want to be just part of the organization and be able to support it from any aspect of it that you can. Okay? We go to the next slide. So in summary, Open19 is about defining common form factor and connectivity. That's what it is. It's not defining servers. Unlike other technologies which have been used in open source, which are actually sharing technology on the server level, this one is not. This one is just setting up a form factor and setting up the connectivity. It's future-proofed for many years, and it will actually be able to be sustained for many years. It's about the community and collaboration. All of our work, all of our development, all of our ecosystem, and the team that works with us are actually a community. Everybody's contributing their time. Nobody's being paid at the foundation. Nobody's actually working for full-time with the foundation. The Open19 is established now. And we have over 75 companies involved in the Open19 project. We hope to see all of them join the foundation in the next few months. It's data center operators, it's system suppliers, it's component suppliers, it's anybody who's actually participating in a data center environment or an edge environment. It will be technology ready for everybody to use in Q4, which is a few days from now. And if you want to join us or actually get early access to this technology, please go to open19.org, join an individual or company, and request early access. If you go to the next slide. Thank you very much. I appreciate your time. I appreciate the morning you decided to spend with me. And if you have any questions, I'll be happy to take questions. Any questions? Unfortunately, I cannot see you, so I'm not sure if there is a question.
¿Preguntas?
If you don't have any questions, so I want to thank you again for actually listening, and apologize again for not being physically in Mexico City. And I hope I'll be able to see you soon in joining our efforts. Thank you.